right, guys, we're going to find real zeros of polynomials. Real zeros, basically solving big polynomial equations. All right, the rational zeros theorem is a big deal. We're going to use this on about every problem today. And that says this: if there's a polynomial that looks, all this stuff, like a polynomial, every rational zero, every possible rational zero is of the form plus or minus p over q, where p is the coefficient of or is the last term. P is the last term right there, like the constant term, and q is all the factors of the leading coefficient. So let me say that one more time. P is all the factors of the constant term, and q is all the factors of the leading coefficient. Let me just show you one here. Okay, it says list all the possible rational zeros of that polynomial. So if I can list all the possible zeros, you put all the factors of the constant over all the factors of the leading. So the last number over the first number, all the factors. So the factors of 6 are 1, 2, 3, and 6. The factors of 2 are 1 and 2. So I'm going to put all these factors over those factors. So if I go 1 over 1, 2 over 1, 3 over 1, 6 over 1, then I'm going to go 1 over 2, 2 over 2, I don't know, I'll put 2 over 3 right there, 2 over 2, 3 over 2, I'm struggling, 3 over 2, and 6 over 2. Now, technically, I don't need the 2 over 2 because I've already got a 1. I don't need the 6 over 2 because I've got a 3. And those are the only possible rational zeros or solutions to that function right there. Okay, so we can't do quadratic formula, stuff like that on the cubes, or fourth degree. So we have to just find numbers that work. And these are the numbers we're going to try to see if any of those are zeros or not. All right, this first one says find the rational zero. So I'm going to start off by making a list. I'm putting the factors of the last number over the factors of this one. Now the factors of 2 are 1 and 2, and the factors of 1 is just 1. So the only thing I have to try are plus or minus 1 and 2, which means it's either positive 1 or negative 1, or positive 2 or negative 2. Something hopefully is going to work in there. So I'm just going to start out by trying the 1. And when I say try, I'm going to do synthetic here. Don't forget your 0. And see if I get a 0 or not. So bring the 1 down. 1 times 1 is 1. Add, multiply, add, multiply. Sure enough, 1 is a 0. 1 does work. Okay, so 1 is a rational zero. Because the degree is 3, I'm probably looking for 3 total zeros, but right now I'm just looking for rationals. I'm going to try another one here. Let's try, I'm picking really nice on purpose. And when I try my second one, I'm probably going to try from these 3 numbers down here. Instead of going back to the original one, I'm going to try this. I'm trying to break the function down, so I'm going to use the new function down here and see what happens. Negative 2 times 1 is negative 2. Add, get negative 1, multiply 2. There you go. Looks good. So there's another 0. That leaves me 1 and negative 1. So I'm going to try negative 1 and see if it works. If I bring down the 1, negative 1 times, that doesn't work. So negative 1 did not work. And the only other thing I have to try is a 2. And if I try 2, bring the 1 down, 1 times 2 is 2. That's 1. So that also did not work. Okay, so the only 2 I found that are rational zeros would be the 1 and the negative 2. Those are the only 2 rational zeros of that function. Now I hadn't made a big deal about this, but I'm talking about rational zeros. I'm talking about zeros that could be written as a fraction. If one of your zeros is imaginary, or if it is square root of 2, it's not going to show up, obviously. These are just rational ones, better known as, I guess, the prettier numbers, right? Numbers without radicals, numbers without imaginary stuff. So here's how we're going to find them. We're going to list all the possible ones, which is, we've already talked about that and already made some list. We're going to divide. We're going to use synthetic to see if it's a 0 or not, like I did on the last slide. If the remainder is 0, we've found one. And then repeat. We're going to repeat that over and over again until we find as many rationals as we can. Okay, so let me show you 2 more, and then we'll be done. All right, it says factor and find all its zeros. Now, even though it says factor, I'm actually going to do what I just did. I'm going to make a list here. Again, factors of 6 are 1, 2, 3, and 6. Factors of 2 are 1 and 2. So I always start out doing that. I put all the factors of this over 1, but I'm going to put them over 2. I got 1 half. I don't need 2 halves because that's 1. I'm going to go 3 halves. I'm not going to put 6 halves because that's really 3. So there's my list right there. And to keep this video short, I'm going to try to guess well, meaning I've already kind of done the problem. So I'm going to try 2, and I'm just picking that out of nowhere. All right, so my coefficients are 2, 1, negative 13, 6 in the function. I'm going to just go through here and see what I get. Okay, so bring the 2 down. 2 times 2 is 4. That's 5. That's 10. That's -3. That's good. There it is. I got there. So that leaves me with these 3 numbers on the bottom. I've got 2, 5, -3. So I'm going to try to see if I can find even another one that might work. Actually, I'm not going to do that. I just changed my mind. Because it's just 3 numbers down here, what just hit me is that's quadratic. That's 2x squared plus 5x minus 3. So I'm going to do slide, divide, slide and see if I can find the other zeros that way. Okay, so I'm going to do slide, divide, slide. Again, to keep the video short, I'm going to do this in my head. So I'm going to put a 2x and an x, a plus 3 and a minus 1. And that does work. So my zeros for this function, the rational zeros, would be the 2 that I found here, the 1/2 that comes from right here, and the -3 that comes from right here. So there's the zeros. It also said factor it. So if I'm going to factor it, I already have 2 factors right there. So to finish up, I would just put the 2 with it also, right, x minus 2. So there's the factored form, and there's the zeros, which is what it asked me to do. All right, we got one more. Okay, it says there's your big function there. It says find the zeros, and then sketch the graph, that'll be interesting. So here we go. Make a list. The good news is there's a 1 in the front, so all I need are the factors of 10 for my list. So I got 1, 2, 5, and 10. That's going to be my list of things that could possibly work. And again, I'm going to try to guess really well on the first time. So let's see. I'm going to guess, I don't know, how about 5? I'm going to guess 5. Again, I'm kind of cheating here just to keep the video short. Bring the 1 down. And when I say keep the video short, if I were just guessing out of the blue, it might take me to my 3rd or 4th guess, which is going to make this video be really long. Okay, so if I guess right the first time, it's going to keep it short. But realize tomorrow in class, it may take us longer than what you're seeing here because we're not going to guess perfect every time, believe it or not. 1 times 5 is 5. Add, multiply, add, multiply. This is working great. Add, multiply. Bingo, got it. So 5 is one of my zeros. Now I'm going to use this new set of numbers, the 1, 0, -5, -2. Try another number from that list. Actually, my new last number now is -2. So that really eliminates my list down to this right here, down to the 1 and the 2. So I think I will try maybe -2. So I'm going to try -2, bring the 1 down, multiply, add, multiply, add, multiply, boom. That leaves me with these 3 numbers, leaves me with an x squared minus 2x minus 1. Looking at that will not factor because there's no factors of -1 that will give me -2. So my only 2 rational zeros are those 2. So to find my other 2 zeros, this did say find all the zeros. It didn't say just rational this time. So I'm going to take this down here, that x squared minus 2x minus 1, and I'm going to complete the square. I'm going to go x squared minus 2x. I'm going to move the 1 over here. Don't forget how to do this. You take half the middle, square it, add to both sides. Half the middle is -1, square -1, you get +1 +1. I get x minus 1 squared. Over here is 2. Take the square root of both sides. Move the 1 over. There's my other 2 zeros. Now, don't forget that is 2 zeros because of the plus or minus. So my 4 zeros are 5, -2, and 1 plus or minus the square root of 2. Okay, so if I go to graph that thing, here's what I know about my graph when I graph it. I know that it's going to cross the x-axis at the zeros. I also know it's even and positive, so the ends are going to go up. So this is going to be a really, really rough sketch here, but I know it's going to cross the x-axis at 5. That's 1 0. It's also going to cross at -2. That's another 0. I also know it's going to cross at 1 plus the square root of 2, and if I punch that in my calculator, I get 2.4. So it's going to cross at 2.4, which is about right there. And if I do 1 minus the square root of 2, it's going to be -0.4, which is about right there. So here we go. Well, again, it's even and positive. So this end's going up, this end's going up, and it's going to cross the x-axis at these other spots. So it's going to look something like that. I'm not exactly sure how high and low it's going to go, without plugging in a whole bunch of more points or checking my calculator, but that's a general shape of what the graph looks like. Good lesson right there. I like that a lot. Make sure you know how to make your list. We're going to use synthetic to break it down. We're going to find the zeros. It's amazing. This is high-level stuff. Hope you enjoyed it. We'll work on it tomorrow. See you then.